This unit is really heavy on solving quadratics by other methods than graphing. So factoring is one of those methods. And there's tons of methods for factoring, and the method that you use depends on the problem. So this flow chart is what I use in my head to go through that process. If you follow this flow chart, then you should not be wrong unless you're doing like a minor calculation issue. So the very first part of this flow chart says first look for a GCF. If you're in my math lab, that could be familiar to you. Otherwise, we've not really talked about it in algebra. What does GCF stand for? Pretty good. So say I have like 4 and 10. What's my GCF between those? Okay, Landon says 2. Anyone disagree? All right, so GCF, yes, is greatest common factor. It's really, in other words, the biggest number you can think of that goes into both evenly. So always see if the smaller of the two can divide evenly into the other, which 4 does not divide evenly into 10. And then if it doesn't, see like what else breaks into 4? Well, 2 goes into both, so that's my GCF. All right, so this example I'll just kind of put like to the side here. So what you're used to is probably figuring out like the GCF between numbers. Well, now you're gonna have variables involved, but those are easy. So say it's like 4x cubed plus 10x squared. All right, do they both have the same letter next to them? Do they both have an x?
Yes.
Yes. So if they all the terms, because sometimes we'll be looking at like 3 terms, 4 terms, whatever. If all the terms have that same letter, then you can factor it out. And how many of them you factor out depends on whichever one is the smallest. So what's smaller, the 3 or the 2? So then I can factor out also an x squared. All right, and that's basically the rundown of how to factor by GCF. So if this were factoring by GCF, because sometimes that's all you can do in that problem, my GCF would be written on the outside of parentheses, and the inside would be whatever I get from dividing by my GCF from each term. All right, yeah, the same thing on top and bottom, it does cancel, so like these x squared will cancel right here, but so far nothing else cancels. What's 4x cubed divided by 2x squared? Okay, what's 4 divided by 2? And x cubed divided by x squared? All right. So we don't remember our exponent rules. So if it's on top of each other, like a fraction, they have the same base, you subtract the exponent. So 3 cubed divided by 3 squared will give me this x. So 3 minus 2 is 1. Does that make sense? Okay. That's how you divide them. And then do it to the next term. Divided by its GCF. The x squareds will cancel. What's 10 divided by 2? And so then close the parentheses. The GCF will stay out there. This is how you factor by GCF. And usually you check your parentheses to see if you can factor more by one of these other methods. But sometimes you're just done after GCF. And if I distribute, I should get my original problem if I did the problem correctly. So, and I did. So questions on factoring by GCF. We'll spend more time on it. It's more like as we go. But regardless, that's always your first step. So check for a GCF. If you check for a GCF, either factored it out or maybe it doesn't have one, see how many terms you have. So if it's 2 terms, there's only one way to factor if it's a 2-term expression. And that's if it's a difference of squares. So this should have been one of the ones that you did as a kind of like a warm-up, because you should know how to do this. But a good amount of time on it, and you could have found it in your notes. So, looking at the very first bullet point example here, right here. Is x squared minus 64 a difference of squares? Okay, we're saying yes. Does it have a minus sign in between? Yeah. Does it have perfect squares on each side? Then yes, so I factor it according to the difference of squares rule, which isn't written, but hopefully you know it or can fill it in. And that's, if it's the difference of squares, it'll look like this, where a and b are the square roots of a squared and b squared. So one is plus, one is minus, in parentheses like that. So then, what is the square root of x squared? Okay, don't overthink it. It is x. Opposite of squaring something is to take the square root, so they cancel each other out and you just get x. So first part of each parentheses of my factoring is going to be x. According to the rule, one of them has to have a plus sign, the other one has to have a minus. And then what's the square root of 64? 8. And if you're not good with square roots, don't worry. There's a button on all calculators pretty much, even your phone calculator. Looks like this. And you can find the square root. See if it's a perfect square or not. Questions on that? How can you check your answer to make sure you did it right? You could, in this situation, FOIL, or in other words, just multiply it out. So like for that GCF example we did, you distribute, so it's not called FOILing, but same difference. Multiply it out. That's what I like about this unit, is that every answer you can check if you have time. So don't waste all your time on a test, like use good time management, but everything can be checked. All right. Next one underneath it. So that one might have been a challenge for you because unless you were in my math lab, I'm not taught you GCF until like 5 minutes ago. So that's always your first step. That's why it's at the very top of the flow chart. Does this one have a GCF? Okay, doesn't sound like we're positive. So look at the numbers first. Is there a common factor between 18 and 2?
Yeah.
So then, and I always kind of write GCF, but kind of write it outside parentheses. What's the biggest number that goes into 18 and 2? 2. Now, do they both have an M? So you can't factor out any M's. Do they both have an N?
Yes.
What's the smallest amount of N's? Be an N swing. Just the N to the first. So you all, if they both have that same letter, then you take out the one that would be smaller. Okay. So that'll be outside parentheses. The GCF just kind of hangs out there. Opposite of distributing is factoring, so that's what that is. And then inside parentheses is what you get from dividing each term by your GCF. If you have the same thing on top and bottom of a fraction, it does cancel, so I'm gonna cancel those. The rest we have to reduce. So what's 18 divided by 2? 9, and the n squared is still there. There's nothing to divide it by. And then the minus, I'm just gonna write, the 2's canceled over here. What's n cubed divided by n? No. No, n cubed divided by n. N squared is correct. So maybe here's a better visual. So if it's n cubed, that's n times n times n, and it's being divided by n. So really just one of them canceled and I have 2 left, n squared. Okay. So, yeah, so we factored out a GCF, questions on GCF. And the reason why this example is still under difference of squares is because look at the parentheses. Is inside the parentheses a difference of squares? Yes, so that you still can factor more and they expect you to. The GCF will stay there, so just copy it over the 2n in your final answer. But these we're gonna factor according to the difference of squares rule. So, I'm not calling on anyone in particular. Hayden, what is the square root of 9m squared? But the question was, what's the square root of 9m squared? Hayden, what's the square root of 9? You're always using calculator, but yes, it's 3. And then what's the square root of m squared? M. That is it. All right, so that'll be the first part of each parentheses. I'll make sure we're paying attention. And then second part of the parentheses, Allison, what's the square root of n squared? It would just be n. So in one of the parentheses, it's plus n, and the other is minus n, and now it's factored. All right, if I multiply the entire thing out, I should get my very original problem, including distributing the GCF and then FOILing and all that good stuff. So yeah, you can also put your hand. Questions on difference of squares? All right, I need more space to write, so I'm going to go to a blank. All right, but there's the rundown on difference of squares, including when there's GCF. So you always check for that first. So following the flow chart, you look for a GCF first, factor one out if there is, if not, move on. Say you have a 3-term expression. There's 2 ways of factoring. And well, I mean, it's kind of the same way, but there's a few extra steps in certain situations. So the first situation that we learned about was when a equals 1, as you can see here. A is 1 because a is always in front of the x squared. So if there's nothing written there, it's 1. When it is 1, what do you do to factor? The diamond method. And when a is 1, you just do the diamond method and then you're pretty much done. So looking at this very first bullet point, there's no GCF because we got some 1s as the coefficient. Not all of them have x's. So we see that it's 3 terms. So we set up our diamond. Ian, what would go on the top of my diamond? Negative 42, because my A was 1, my C is negative 42, multiply them and put them on top. Peyton C, what's going to be my B? Negative 1. And yes, the signs do matter. It'll make a difference. Any questions on this? All right, now I need 2 numbers that multiply to the top but add to the bottom. Don't shout them out if you think you find them. You can kind of think about it for a little bit. Like the puzzle. So we're multiplying to the top and adding to the bottom. Yes. All right. If you're stuck, you can't think of the numbers that do that. What are some numbers that multiply to 42? 7 and 6. See if those can work somehow. Other numbers, you could have tried 42 and 1. 2 times 21, whatever, I'm sure there's more. But 7 and 6, I think I could play around with a negative and get a -1 when I add. I know one of them has to be negative because it multiplies to a negative. So which one will have to be negative to add to a negative? The 7. So I always think what multiplies to it first, and then I play around with the negative sign if I need to. But then once you find that, the rest of it's easy. Just x minus 7, because there's negative here, and x plus 6, which is positive in there. Questions on that first example? All right, we could absolutely do the second one through GCF first, is what that one is about. But I do want to spend a little more time on the one we learned yesterday. But any questions before we do this one? So this one is when A is not 1. If A is not 1, really you just have a couple extra steps. So you can still do the diamond method, but first, before even doing that, see if there's a GCF. So in this one right here, all right, in this one right here, is there a common factor between 30, 27, and 6? 3, and that's the biggest number we can think of that does that. 6 doesn't divide evenly, but 6 can be broken down into 3 and 2, and 3 works. So can I factor out any x's? Do they all have x's? So then I can just factor out a 3. So we have to do that first. Otherwise, the numbers aren't really that easy to work with, and you'll just get it wrong anyway. So just factor out the GCF first. Divide each term by your GCF. That'll go inside parentheses. What's 30x squared divided by 3? 10x squared. What's negative 27x divided by 3?
Negative 9.
Negative 9x, yeah. And then 6 divided by 3. 2. All right. So that's just from factoring out GCF, which you have to do. So far in like the other lessons, there wasn't one, but now just kind of make sure you don't skip that stuff. All right, if what remains, so in the red, in the parentheses, is what we get after factoring out GCF. If what remains is something you can factor with one of the other methods, then you have to do it, otherwise you're not done. So, it's a trinomial, A is not 1, what is A? A is 10. So, still do your diamond method. What's gonna be my A times B in this one? Don't tell me, Christina. My A times C in this one. 20. And then Alyssa, what's gonna be my B? -9. So you set up your diamond, you set up your puzzle essentially, and try to find 2 numbers that multiply to the top and add to the bottom. Any suggestions? Landon? -5 and -4. If you try 2 and 10 or 20 and 1, there's no way you can play around with that to get a negative number. But 5 and 4, multiply to 20. But to make it add to a negative, they both have to be negative. That's just it. But it has to work for the entire diamond, otherwise you did not find the correct numbers. So copy your GCF over. So now my parentheses, so far at least, are x minus 5 and x minus 4. But like I said, because A was not 1, you got a little bit extra. you have to now divide by A from your factors. So GCF, leave it alone. But what was my A again? 10. If it works out to a whole number, great. If it doesn't, make sure you simplify and slide. So they say slip and slide. I think simplify and slide is better. So simplify those fractions. What does 5/10 simplify to? 1/2. 4/10, what does that simplify to? All right, so I know we're not huge fans of fractions, but now that we're done with state testing, I'm not really limiting your use of Desmos. So if you struggle with that, you can type the fraction into Desmos 4/10. It gives you a decimal, and you can do this with almost any like calculator too. There's usually a decimal to fraction button. So on Desmos, it's this one, like to the left of it right here. And now it gives you the simplified fraction. So it'll be 2/5. And yes, it is negative. I just put the minus in there. Good there? So you don't have to use fractions as an excuse to get decimals. Okay. So that's what we have. So we did the simplified. Now we have to slide any remaining denominators in front of the x. Now when we FOIL, we can get what we want. So rewrite it, it's gonna be 2x minus 1 for the first one, and 5x minus 2 for the second. Don't forget the GCF was from earlier, it stays there. But now when I FOIL the parentheses, what's 2x times 5x? 10x squared, which is what we're supposed to get. If we had just stopped up here, we would have just gotten x squared, which doesn't make any sense. So what we're doing is like the opposite of multiplying. So you could always check your answer by multiplying. Question? Yeah? Yes. All right, so we don't have to start the test for like 4 more minutes because you only need 25 minutes. So, I will tell you, we will do this one right now, but the grouping one, we haven't learned yet. So we'll pull that out when we do learn it to make sure our graphic organizer. For the one under here, let's do that one real quick. What are you supposed to do as your step 1 for any factoring problem? Check for a GCF first. That's why it's the very first bubble. Does this one that my mouse is on, does it have a GCF? Yeah. Does 2 go into 2, 20, and 50? So you have at least a 2 for a GCF. Can you factor out a variable?
No.
No. So first factor out a 2, which means divide each term by 2. So 2's cancel on the first one. I just have w squared. What's 20w divided by 2? And 50 divided by 2. Okay, great. Next part, I'm going to draw a line between these. So GCF will stay there. You don't need to mess with it anymore. But do check your parentheses. Does this look like something we've learned how to factor? Yes, it's a trinomial and A is 1. So that means I can just do my diamond method. And once I find my 2 numbers, that multiply to what? And add to, then I can be done. So what 2 numbers will make that happen? 5 and 5. And both positive because it adds to a positive. So my parentheses are now W plus 5 and W plus 5. You could, I'll write both ways that you could see this. Since they're the exact same parentheses, you could also write it as W plus 5 squared like that. But yeah. Feeling better about factoring? Okay. The only thing we haven't covered yet is grouping, so we'll get to that, so we don't lose these notes. Feel free to take out your other notes. I'm gonna give you the password for the quiz. So same testing procedures as all